All right, welcome back. So we just took a look at the overview on the architecture of vSAN, but one other very important element on how vSAN functions is the way how it actually deals with the actual data. It's not a block level file system like VMFS, which is organized into disk blocks, and it's not a file level file system like a NAS is dealing with file blocks. No, vSAN is an object-based file system, right? It's object-oriented, meaning the typical things that we think of as files are actually represented in vSAN as objects. So for instance, every virtual disk is an object. The snapshot delta files of a VM's snapshot configuration, right? The delta file, that's an object. The swap file is another object, and if you ever suspend a VM, the memory state file that gets created is also an object. And all the other files that make up a VM, the VM's home namespace is yet another object. In fact, when you assign a VM a vSAN storage policy, what happens is the VM home namespace object is the primary receiver of that policy, and then all the other objects will by default inherit the same policy. However, it doesn't have to be that way. Virtual disks can each get their own policy. So you can set a very granular control because remember, your VMs are the first class citizens. But in the end, what does this really mean, right? So they're objects, big deal. What's interesting is the way in which the objects are then handled at the vSAN level is interesting because that's going to be quite dependent on the RAID configuration. So remember, RAID is done at the VM object level, not at the disk level. So here we happen to have, in our example, we've got 3 hosts in a cluster. So we've got 3 hosts. That's actually 3 places where VMs could be placed. If I decided to create a VM that has been configured as a stripe, RAID 0 stripe configuration, right? If it's a RAID 0 stripe with maybe 3 stripes, what's going to happen? Well, imagine this VMDK object, right? The virtual disk is an object, and say it's 100 gigs. Well, what's going to happen? This object is going to be broken up into something known as components. The components are actually going to then be placed based on the RAID policy. So if this was a RAID 0 stripe with 3 stripes, well, then this 100 gig disk will be broken up into 33 gigabyte components, right? So 100 gigs gets broken up into 33 gigabyte components. So a 33 gigabyte component will be on this host, a 33 gigabyte component will be on this host, and a 33 gigabyte component will be on this host. Probably that will be what happens. If, on the other hand, I decided, let's go ahead and create a RAID 1 mirror of our virtual machine, well, now my 100 gigabyte object will be broken up into 2 components, each one being the same, right? The replicas of each other. So you'll have a 100 gigabyte component on one host, a 100 gigabyte component on another host. In fact, when it comes to mirrored VMs, the mirrored components have to be on different hosts. They cannot be in a single point of failure. So that happens to all the objects. If you've got a mirrored VM, every object is basically then been mirrored in our vSAN environment. So just be mindful of where the overhead resides. When it's vSAN, the overhead is at the VM level. It's not at the disk level like you might think a LUN would be, right? A LUN, you'd have like a RAID 1 LUN. Well, the LUN itself has been mirrored. But if you have RAID 5, on the other hand, then that's going to cause the VM to be distributed across multiple components across multiple hosts. Now, another aspect to vSAN are the storage providers. With vSAN, it had been traditionally the hosts were the storage providers. It makes sense because that's where vSAN actually takes place, right? vSAN isn't handled by vCenter in that it doesn't direct where anything goes. That's all being done by the hosts. So in older versions of vSAN, it was actually the hosts that were the storage providers. But you notice here, this is vSphere 7. Things are a little bit different. vSAN now has what's called an internally managed storage provider. We don't even need to register it. It's automatic, and it's actually registered in vCenter. It's hard to see in our example here. It says internally managed, so that tells us one thing, but it's over here, the URL. That's in our lab environment. That's the start of the vCenter server's URL. You know, compare that to an IO filter, which is definitely a host-based storage provider. So here we see the start of the URL that represents an ESXi host. But the vCenter server is yours internally managed for vSAN. Mostly all you have to worry about is the fact that it's done for us, right? We don't need to worry about registering the storage provider for vSAN in any version of vSphere. Now, creating a storage policy. How do we do this? Well, basically a storage policy, when it comes to vSAN, there's actually already a built-in default one, basically mirrors the VM. If we were to take a look at what that policy looks like, go over to your storage policies and profiles section in the vSphere client, find the storage policy called vSAN storage policy, edit that policy, and you'll see what it's made up of. It's basically made up of a bunch of different rules of what vSAN can provide. It provides what's called a site failure tolerance of none, right? Because one thing interesting about vSAN, it does allow you to have a stretched cluster that mirrors data across two different sites within the same metropolitan area. It does support one failure to tolerate. When you build your RAID configuration, you're basically defining how many failures of your object's components could fail, and the data is still going to be available. So if you have one failure to tolerate, you basically have two copies of your data. That's a typical RAID 1 mirror. There's other options. There's RAID 5, there's RAID 6, there's also a 3-way mirror, there's a 4-way mirror. So there's just different types of protection. We can set number of stripes per object. We can add an IOPS limit per object. We can set object space reservation to define how much space we'd like to reserve for thin disk provisioning. vSAN is always thin provisioning by default, but if you would like, you can set the objects to be more thick provision if you need it to. You can set aside flash recache reservations. That only is applicable for hybrid storage. And then there's also the objects checksum. You can disable that. vSAN keeps data safe by providing checksum operations. It's a really good thing. But if your application in the VM is already doing checksum, like for instance, you're running Oracle RAC, well then you might as well just disable it at the vSAN level. There's no point in doing double checksums. And then forced provisioning. We'll take a look at what that is here in a few moments. But that's the default policy. Basically, a VM is mirrored. Anytime you put a VM in a vSAN data store, it's going to get mirrored by default. So create our own policy. Well, let's see here. We'll create our own policy. We specify we'd like to create a policy, select the vSAN storage checkbox, and then the wizard's going to essentially bring you to this one area of all the different vSAN rules. The vast majority of vSAN rules are going to be based on what RAID level you would like to apply the VM. Notice in the vSAN settings, there's three main tabs. There's availability. Next to that is advanced policy rules. And next to that are the tags. 99% of the time, when you build a vSAN policy, it's going to be based on what RAID policy you would like to apply. In fact, you'll notice right here, we're specifying failures to tolerate. That's how redundant you want your VM to be, right? How many copies of the data or how many levels of failures can occur and our data is still fine. So we could say no data redundancy. So basically building a RAID 0 VM, it's going to essentially be striped. You can have the VM support one failure. Now there's actually two different ways to provide one failure protection. The typical RAID 1 mirror, which does require you to double your VM's storage footprint, right? You got a 100 gigabyte virtual disk. It's going to need 200 gigabytes of disk space to mirror it. Meanwhile, the other type of one failure to tolerate is what's called RAID 5, where in this case, you actually have a 3-stripe configuration with one more stripe being parity. So it's basically 4 stripes long. The VM is distributed with 3 stripes for its data and one more stripe for its parity. So it's basically 1 1/3 extra capacity needed as opposed to a mirror, which is 2 times the space required. So what we consider RAID 5 is, it's a space saving solution. RAID 5, by the way, is only available with all flash configurations. So you're basically, going with the all flash, paying the extra for the performance enhancement and saving space with a RAID 5 type of configuration, right? Because it's going to use 1/3 less space than a RAID 1 implementation would. Similarly, there's 2 options that support 2 failures. You either do a RAID 1 mirror where there's 3 copies of the data, so that means 3 times the space is needed for the VM, or you can do RAID 6, which is basically 4 stripes plus 2 more for parity. So that is essentially 1.5 times extra capacity compared to a 3-way mirror. That's half the space. So it's another space-saving option. And then for those who really need to make sure their data is always available, you can have 4 copies of the data, right? A 4-way mirror supporting 3 failures and your data is still good. That's a lot of extra copies. So you can choose your RAID policy. You can choose whether or not you support a stretch cluster. A stretch cluster, basically, you've got your vSAN cluster stretched across 2 sites in the same metropolitan area, and your VM can then be mirrored across the sites, providing some disaster avoidance. Pretty neat feature. And then you pretty much hit OK and you're good with your policy. But, you can go in those advanced policy rules and make changes there. But most of the time, we don't need to make these changes. For instance, the number of stripes per object, it's set to 1 by default. It'll actually do this for you automatically based on how big your data set is. Remember I said an object is made up of multiple components? Well, the maximum component size is actually 255 gigabytes. While that may seem like a decent sized number, for a lot of environments, that's actually not a really big size virtual disk. Imagine you build a 300 gigabyte disk, that's bigger than the max component size. What vSAN will do, it'll automatically break that up into 150 gig components for you. So it's going to do striping for you automatically. So you don't really need to set that. IOPS limit per object lets you throttle I/O to a VM. That basically is for those VMs who just don't need the performance. You're going to throttle them. You probably will leave that alone most times. Thin provisioning is actually the other big thing here, object space reservation. Thin provisioning is the default. That's what you generally want. You want to be able to save space. If you wanted to add some thick provisioning, you actually have some choices. You can have it be 25% thick provision, 50%, 75%, or full thick provision. But again, most times just leave them at thin. The flash recache only applies for hybrid environments because the cache in a hybrid environment actually performs mostly read caching and some write caching, where with all flash, the cache is actually 100% write caching. So if you have all flash vSAN, there's no relevance here when it comes to that. Disable object checksum, we talked about that already. If you're doing it in your application, you can turn it off in vSAN if you like Oracle RAC. And then the last one here, forced provisioning. If you try to build vSAN in an environment that doesn't support it, like for instance, you decided you want to do RAID 5, right? RAID 5 actually needs 4 hosts in a cluster. If you only have 3 hosts in the cluster, it won't be able to support RAID 5. If you try to give a VM a RAID 5 policy where there's only 3 hosts, it'll actually give you an error message. It won't let you apply the policy. Unless you select that, forced provisioning, it'll actually place the VM in that policy with a RAID 0. So it has no redundancy at all, even though you set it for RAID 5. Why on earth would you do this? Good question. If you are expecting new hardware to come in relatively soon, like you have 3 hosts and you're expecting 3 more hosts, so you'll have enough hosts soon to support the policy, you could do that. Give the VM a RAID 5 policy, force provision it so at least it's got the RAID 5 settings, but it's only going to take effect when you have the extra hosts. So it doesn't have any redundancy until you do this, which I think is a little odd. So maybe I would think give it a RAID 1 mirror setting to start, and then when you have the extra hardware, because mirroring actually needs 3 hosts, because how mirroring works is actually 2 nodes, and then 1 more is the witness tiebreaker. So you need 3 hosts for mirror, but you need 4 hosts for RAID 5. So I could at least mirror with the 3 hosts, get redundancy, and then when you have the extra host, well, now it's time to to apply the RAID 5 policy. So let's try it out. We're going to have you do lab number 6. We already have vSAN, right? That's that compute cluster. I say compute 01, that's a vSAN cluster. So it's all ready to go. All we need to do is take a look at what the default policy is, which is basically a RAID 1 mirror. We'll go ahead and create a custom policy with 0 fault tolerance. You're going to basically create a RAID 0 policy and assign that to a policy to a VM, but you're going to put the VM in non-vSAN storage. So that's not going to work out that well, right? You give a VM a vSAN policy and you put the VM in a non-vSAN data store, just to show, hey, we're not going to force the VM to get placed into vSAN. You still have to put the VM in a vSAN data store. Once you do that, now the VM is compliant. And then finally, we'll go ahead and create an invalid policy, right? Speaking of RAID 5, we're going to give your VM a RAID 5 policy. We only have 3 hosts, so that's not going to work too well. You'll see what the error message looks like that. So we'll have you go ahead and do the exercise. We've ended this lesson though. So we did identify the components of the vSAN architecture, and we took a look at creating a vSAN storage policy. You are going to do that in the lab right now, and we'll see you in the next lesson.